The next question is question 2 on page 7 of the document. It says transverse waves with a wavelength of 0.45 meters travel along a string at 0.25 meters per second. The amplitude of the wave is 0.20 meters. Define a transverse wave. A transverse wave is a wave in which the particles of a medium vibrate perpendicular to the direction of the motion of a wave. So let me just show you the difference between the direction of a transverse wave and of a longitudinal wave. If you look at a transverse wave, and if you look at a longitudinal wave, okay, so the transverse wave, the motion of it is going up and down, up and down. The motion of a longitudinal wave is going to the right each time. But the direction of movement of this transverse wave is to the right-hand side. The direction of movement of a longitudinal wave is also to the right-hand side. Therefore, you can say for a transverse wave, since it's going up and down and the direction of movement is to the right, this is perpendicular to each other. It forms a 90-degree when they're moving. But this would be parallel to each other because they're in the same direction. So this is perpendicular, this is parallel. This is transverse, this is longitudinal. So the question was basically saying, what was the definition of a transverse wave? And it is a wave in which the particles of the medium vibrate perpendicular to the direction of the movement of the wave. The next question is asking you to draw a label diagram showing two wavelengths of the wave to illustrate your answer. Label the directions of disturbance and propagation of the amplitude and the wavelength. Okay, so I have a wave drawn here. From this peak to the next peak, this is the wavelength. From the equilibrium, the solid line is equilibrium, to the maximum point from here to here, this is the amplitude of the wave. The direction of this wave is going from left to right, so this would be the direction of propagation. The direction of disturbance is going up and down because it's being vibrated up and downwards. So this is direction of the disturbance. So once you label all of this, you'll get a full 4 marks. Two of the wavelengths is represented from here. From the beginning of the equilibrium, all the way past the equilibrium to the equilibrium again. So a peak and then the minimum point. This is one wavelength. Then from the equilibrium again to the peak, going past equilibrium down to the equilibrium again, that is another wavelength. So 2 wavelengths is represented in the diagram, and you're going to get a mark for showing that. The next question is asking you to calculate the frequency of the waves. So you have the formula velocity equals to frequency times lambda or times wavelength. Frequency will equal to velocity over wavelength, and this would be the velocity that they've given us is 0.25 divided by the wavelength of 0.45, and this will give you the answer of 0.56. Unit of measurement is hertz for frequency. For the next question, 2.4, it said calculate the period of the waves. Now the period is the time. So to calculate time equals to 1 over the frequency, and this would be 1 over the frequency we just calculated is 0.56, and this will be 1.79. Unit of measurement for time is seconds. The next question asks, when the frequency of wave is doubled, how are the following quantities affected? Right, only decrease, no change, or increase. So they want to know the speed of the wave. That would increase. Then the next question, the amplitude of the wave, that would stay the same. There's no change.